Hi everyone, I am Mr. P. Rajendra Bhanuteja. In this video, we'll discuss the different questions related to probability. Coming to the first question, four unbiased coins are tossed. What is the probability of getting two heads and two tails, or exactly two heads? Question will be asked like this. This is the question from coins concept. Have a look. For example, a coin is tossed for four times, four times. That means n of s sample space is nothing but 2 power 4, 2 power 4, which is 16. We know that the general sample space for the coins is 2 power n. Since it is tossed for 4 times, it is 2 power 4. Now, we have to find what is n of e, that is the number of favorable events or number of possible events. For example, have a look. He is asking two heads and two tails. So two heads and two tails. For example, we may get the combination like head, head, tail, tail. Okay. Or else head, tail, head, head. Next combination. Tail, head, head, tail. Or else tail, tail, head, head. Or tail, head, tail, head. Or head, tail, tail, head. So these are the possible combinations. So total, there are six number of combinations. Six number of combinations. Head, head, tail, tail means head on the first coin, head on the second coin, head on the third coin, tail on the third coin, tail on the fourth coin. So total, there are six chances. So probability of occurring a event is nothing but n of e 6 by n of s 16, which is 3 by 8. Answer is 3 by 8. Option A is right. Okay. Or else we can solve this question in this manner too. Have a look here. Method 2. Since I want two heads, two tails, total four different things. Okay. Anyhow, n of a sample space is same. That is 2 power 4, which is 16 sample space. Now coming to n of e. Two heads and two tails. Total four different things. Four different things can be arranged in 4 factorial ways. By, since head is repeated for twice, 2 factorial, and tail is repeated for twice, 2 factorial. That is 24 by 2 into 2, which is 4. So answer is 6. N of E is 6. Instead of trying for these combinations, we can directly solve the question with this method. So probability is nothing but 6 by 16, which is nothing but 3 by 8. Okay, this is the first question. Now have a look of second question. 5 unbiased coins are tossed. Sir, 5 unbiased coins. N of a sample space is 2 power 5, which is 32. 32. Now, I want to find out N of E. N of E, that is the possible events. That is nothing but, see, have a look. 3 heads and 2 tails. Total 5 different things. 5 different things can be arranged in 5 factorial ways by head is repeated for thrice, 3 factorial into tail is repeated for twice, 2 factorial. Okay. So it is nothing but 120. 5 factorial is 120 by 6 into 2, 12. You'll get 10. So probability P of E is equal to P of E is equal to 10 by 32, which is 5 by 16. I hope it is clear. Answer is 5 by 16. 5 by 16. Now, Have a look of third one. 3 fair coins are tossed. Sir, as soon as you have seen how many times it is tossed, you have to find out the sample space. That is 2 cube, which is 8. Okay, 8. Have a look here. So 3 fair coins are tossed simultaneously. N of S sample space become 2 cube. 8. What is the probability of getting at least 2 hits? Have a look, everyone. At least. If you find a word called at least, minimum is 2, maximum is 3. Since the coin is tossed for thrice. For example, if he has given at most, at most, at most means maximum 2, minimum 0. For example, they have given at least 2. At least 2 means minimum is 2, maximum is 3. At most 2. If they given at most 2, that is maximum 2, minimum 0. Okay, at least and at most. You have to remember these 2 points in your mind. Now, what is the probability of getting at least 2 hits? He is asking at least 2 hits. Sir, there is, for example, if you consider, I'll tell you the possible combinations. Head, tail. We have to get at least 2 hits. That is, minimum 2 we have to get 2 and 1 is tail. Next one, if you consider head and tail combination, 3 out of 3 are heads, tails are 0. Okay, either this combination can be suited or this combination, head and tail combination, 3-0 suits. Now, have a look here. That is, 3 coins, 2 are head, 3C2 into 3 coins, 1 is tail, 3C1. R means plus. 3C3, 3 out of 3 are heads into 3C0. So 3C2 means 3. 3 into 1, this is 3 plus 3C3 is 1. So total 4 number of combinations. This is N of E, sir. Possibilities are 4. 4. I want to find out the probability. P of E is equal, probability of occurring a event. P of E is equal to 4 by 8, which is 1 by 2. 1 by 2. Option C is the right one. I hope it is clear. Or we can find out one thing. That is, for example, see, I want to get probability of getting. No, understand this method. This will be very useful for the upcoming questions. Probability of at least 2 heads. Probability of at least 2 heads we want. That is, we can get by using sample space minus probability of not getting 2 heads. Probability of the cases which are not getting 2 hits. Which are not getting 2 hits. We can take like this. This is nothing but N of E, sir. N of E is equal to sample space minus probability of not getting 2 hits. That is, sample space is 8 minus probability of not getting 2 hits. That is, we can get the combination like head, tail, tail, or we can get other combination as tail, tail, tail. Okay, see, head, tail, tail. These are 3 combinations. That is, see, have a look. Head, tail, tail will get, or tail, head, tail will get, or tail, tail, head will get. So we can arrange this case in 3 ways. So 3 plus R means plus tail, tail, tail one time. So 8 minus 4, which is 4. Which is 4. So probability of occurring a event is nothing but 4 by 8, which is 1 by 2. So this method will be helpful for the upcoming questions. This method will be helpful for upcoming questions. Now, have a look of next one. Fourth question. Fourth question. Okay, have a look here. 5 coins are tossed once. No, since 5 coins are tossed, 2 power 5, which is 64. Okay, sorry, 2 power 5, which is 32. This is nothing but the sample space. Sample space here is 32. 2 power 5, which is 32. Now, what is the probability of getting at most 4 heads? Sir, as I told you, at most means maximum 4, minimum 0. Maximum 4, minimum 0. This is the case we have to keep in mind. Now, have a look here. Have a look. I want to get the maximum of what is the probability or how many cases I am getting at most 4 heads. At most 4 heads. That is nothing but sample space minus number of event getting more than 4 heads. More than 4 heads. Now, since the coin is tossed for 5 times, there is a case with head, all the 5 are heads. So this is the case we have to eliminate because we have to get only maximum of 4 heads. But there is one case which is having the 5 out of 5 as heads. So eliminate that. Total sample space is 32 minus 1. What is this one? All the 5 are heads. This is the case. All the 5 are heads. So you'll get 31. So therefore, probability of occurring a event is nothing but n of e by n of s. N of e is 31, n of s is 32. So 31 by 32. Option A is the right answer. Option A is the right answer. I hope it is clear. Next one. Now, coming to the dice concept. A die is an unbiased die is tossed. What is the probability of getting number 5? Now, for example, if I throw a dice for one time, we all know that there are 6 possibilities. Either we'll get 1 or 2 or 3 or 4 or 5. We'll get or 6. We have these 6 combinations, 6 possibilities. Now, what is the probability of getting number 5? As this is the basic question, we'll get only 1 out of 6. So, answer is 1 by 6. Now, have a look here. What is the possibility or what is the probability of getting a prime number? For example, if you observe these 6 numbers, the prime numbers are 2, 3, 5. These are the prime numbers. So, we have 3 chances out of 6. Answer is 3 by 6. Now, what is the probability of getting the multiple of 3? Now, if you observe the numbers, the 3 multiples are only 2, 3 and 6. So, we have 2 possibilities out of 6. So, answer is 1 by 3. Now, the number greater than 4. If you consider possibilities, the number greater than 4 are 5, comma 6. We have only 2 numbers. So, 2 possibilities out of 6. So, answer is 1 by 3. Square value. If you consider square value, 1 square is 1, 2 square is 4. We have only 2 possibilities to get the square value. Either we have to get 1 or we have to get 4. Either 1 or 4. That is, there are 2 possibilities out of 6. which is 1 by 3. Now, cube values I want. Cube values. 1 cube is 1. So we have only one chance. So 1. Answer is 1 by 6. 1 by 6. These are the possibilities we should keep in mind. These are the possibilities we should keep in mind. So I hope this question is clear. This is very basic question related to days. Now, have a look here. We know that this is the sum possible diagram which we have discussed before in the previous videos. Now have a look. 2 days are thrown simultaneously. What is the probability of getting the sum or total as 6? For sum or total as 6, we have, from this diagram we have 6 possibilities. So 6 possible cases. So for 7, as I told you before, we'll get either 3 on the first day, 4 on the second day, or 4 on the second day, 3 on the first day, or 1 on the first day, 6 on the second days, 6 on the first days, 1 on the second days, or 2 on the first days, 5 on the second days, 5 on the first days, 2 on the second days. Total there are 6 possible cases. Total there are 6 possible cases. So 6 by total. See, the dice is thrown for 2 times. What is the sample space here? Which is 6 square. 36 is the sample space. 36 is the sample space. So 6 by 36. Answer is 1 by 6. 1 by 6. That is the first question, dears. Now, have a look. The sum is the prime number. Sum as a prime number. Now, if you observe this sum possible diagram, if you observe this diagram, in this diagram, what are the prime numbers you have? 2 is the prime number, 3 is the prime number, 5 is the prime number, 7 is the prime number, and 11 is the prime number. These are the prime numbers. Now, sum possible as 2, only for once. Sum possible as 3. It will happen in 2 cases. Now, sum possible as 5. So 4 chances. 4 chances will be there. Sum possible as 7. 6 chances will be there. Sum possible as 11. 2 chances will be there. So total, if you add all these, you'll get 15. So 15 by sample space is 36. 15 by 36. Answer is 5 by 12. Answer is 5 by 12. I hope it is clear. Next one. The sum as the multiple of 4. If you observe this sum possibility diagram again, what are the multiples of 4 here? First one is 4, sum as 4. Next one, sum as 8, sum as 12. Now, if you observe the possibilities, for sum, possibility is 3. The sum of 4, possibility is 3, plus sum as 8, possibility is 5. Sum as 8, possibility is 5. Sum as 12, possibility is 1. So if you add all these, you'll get 9. 9 by 36. That is 1 by 4. I hope it is clear. 1 by 4. Now, have a look. The sum which is greater than 8. Now we have to find out the sum which is greater than 8. Sir, if you observe, there is a possibility of 9, 10, 11, 12. These are the sums which are greater than 8. So, we can have the chance of getting sum as 9, sum as 10, sum as 11, sum as 12. Now, if you observe the possibilities, 9 sum possible for 4 cases, plus sum as 10 possible for 3 cases, sum as 11 possible for 2 cases, sum as 12 possible for 1 case. So total if you add, you'll get 10 out of 36. 10 out of 36. That is 5 by 18 is the probability. Okay. Next one. Have a look. The sum as a square value. I have to get sum as a square value. Sum as a square value. Have a look here, dears. See, I can get the sum as 4. 4 is a square value. And I can get the sum as 9. 9 is a square value. 2 square and 3 square. See, the possibility. How many possible cases are there? 3. And for 9, it is 4. So total possibility, probability of occurring a event is nothing but n of e by n of s. 7 by 36. 7 by 36. I hope these are the 5 possible cases. I hope it is clear. Yes. I hope it is clear. Next one. I will clear. A dice is thrown twice. Okay. See, as soon as you have seen how many throws, find out the sample space. N of s is equal to 6 square, which is 36. Okay. N of s is, the dice is thrown twice. What is the probability that at least one of them comes up with number 4? We have to find out the probability that at least one of them comes up with number 4. Now, have a look here. Have a look here. I'll write the possible combinations. We'll get 1 on the first dice, 4 on the second dice, or 2 on the first dice, 4 on the second dice, 3 on the first dice, 4 on the second dice, 4 on the first dice, 4 on the second dice, 5 on the first dice, 4 on the second dice, 6 on the first dice, 4 on the second dice. And if you have done 4 on the first dice, 4 on the first dice, 1 on the second dice, 4 on the first dice, 2 on the second dice, 4 on the first dice, 3 on the second dice, 4 on the first dice, 4 on the second dice, 4 on the first dice, 5 on the second dice, 4 on the first dice, 6 on the second dice. At least one number should be 4, right? So at least means minimum is 1, minimum 1, maximum 2 out of 2. So since we have 4 for twice, eliminate this. So we have how many combinations now? Eliminate 1, 4, 4. So we have 11 combinations. So n of e is 11. Probability of occurring a event is 11 by 36. 11 by 36. I hope it is clear. Next one. 2 dice are thrown simultaneously. What is the probability of getting 2 numbers whose product is even? So here he given one condition. The number on the first dice, the number on the first dice, dice 1. If you multiply the number which is present, which comes on the second dice, the product should be even. This is the condition they given. Now, if you observe, we have studied some basic formulas in our field of days. That is, odd number into odd number. That is, if all odd numbers appears on the first die, if odd number appears on the second die, the product should be odd number. Product should be odd number. We don't want this case now because we want the product as even. Now, if you observe the second case, even number multiplied with either even or odd number. If you multiply even number with even number or if you multiply even number with odd number, you'll get even number. So we have to observe this case now. Since he asked the product of the numbers falls on the 2 dice should be even. Now, have a look here. Have a look here. For example, if you consider one odd number, it is 1. 1. So, 1 on the first dice, 2 on the second dice gives us even product. 1 on the first dice, 4 on the second dice gives us the even product. 1 on the first dice, 6 on the second dice gives us the even product. If you consider 2, that is even number. So, 2 on the first dice, 1 on the second dice, 2 ones are 2. 2 on the first dice, 2 twos are 4. 2 threes are 6. 2 fours are 8. 2 fives are 10. 2 six are 12. All are even numbers. So if you consider one even and odd combination, you have 9 cases, 9 possibilities. Now, if you consider 3 is an odd number, 4 is an even number. For this, you'll get 9 choices or 9 cases. Next one, 5 is an odd number, 6 is an even number. Again, you'll get 9 cases. Total n of e is nothing but 9 plus 9 plus 9. Total 27 cases. 27 possibilities are there for the given condition. So probability of occurring a event is equal to 27 by total. See, if the dice is thrown for 2 times, n of s here is 6 square, which is 36. So 27 by 36 is the answer. 27 by 36, which can be treated as 3 by 4. 9 threes are 9 fours are. So answer is 3 by 4. Answer is 3 by 4. I hope it is clear. So repeat the question for once or twice. Definitely you will understand the concept. Next one. Have a look here. 2 dice, one blue, one orange are rolled simultaneously. Sir, forget about these color combinations. Just to confuse you, they have given. So, have a look here. 2 dice, one blue, one orange are rolled simultaneously. What is the probability of getting equal numbers on both? Sir, equal numbers means one on the first day, one on the second day, and so on. 6 on the first day, 6 on the second day. Total n of e is nothing but 6 chances, 6 possibilities. 2 days, 2 days. So sample space n of s is 6 square, which is 36. So answer is 6 by 36, 1 by 6. So option B is the right one. Next one, prime numbers on both. We have to take prime numbers on both. For example, I'll write the combinations. 2 on the first days. Okay. 2 on the first days. 3 on the second days. Okay. 2 on the first days. 2 on the second days. 2 on the first days. 5 on the second days. Next one. 3 on the first days. 3 on the second days. 3 on the first days. 5 on the second days. Okay. Next one. 3 on the first days. 3 on the first days. 2 on the second days. 3 on the first days. 2 on the second days. Okay. I hope it is clear, sir. Next one. Next one. Which is 5 on the first days, 2 on the second days, 5 on the first days, 3 on the second days, 5 on the first days, 5 on the second days. Total, there are 9 combinations, 9 possibilities we have. So 9 by 36, answer is 1 by 4. I hope it is clear. Answer is 1 by 4. There are 9 number of possibilities. I hope it is clear. Next one. In a single throw of 2 dice. Sir, here he is throwing 2 dice. That is n of a sample space is 6 square, which is 36. Now, what is the probability of getting multiples of 2 on one and multiples of 3 on the other? We have to observe multiple of 1. That means we don't know whether it is the first dice or second dice. Multiple of 1 on the first dice or multiple on the 3 on second dice. No condition given like that. Either of these dice should consist of, might consist of the multiple of 2 and multiple of 3. Have a look here. For example, if you consider dice 1, multiple of 2, 2, 4, 6. These are the multiples of 2. If you consider dice 3, multiple of dice 2, multiple of 3, sir, 3 comma 6. Now, check with the combinations. Check with the combinations. We'll get either 2, 3, 2 comma 3, or we can get 3 comma 2. Okay, we can get 4 comma 3 or 3 comma 4, or we can get 6 comma 3 or 3 comma 6. Okay, we'll get like this. Or else we can get the combination 2 comma 6 or 6 comma 2. Next one 4 comma 6 or it is 6 comma 4, or else you can get 6 comma 6. Total, if you observe, there are 11 combinations. So 11 possibilities. N of E is equal to 11. So answer is probability of occurring a event is nothing but N of E by N of S. So 11 by 36 is the answer. 11 by 36 is the answer. Okay. Next one. Have a look here. 3 dice are thrown together. Now 3 dice are thrown. N of S is equal to 6 cube, which is 216. Sample space is 216. Now, find the probability of getting a total of at least 6. As I already mentioned in the previous video, previous questions, at least minimum it should be 6, maximum it is 18. Since the 3 days are thrown, the maximum possible is 18. So minimum at least 6 are given, that is minimum 6, maximum 18. That means we have to add this 10 plus 15 plus 21 plus, okay, 25 plus 27 plus 27 plus 25 plus 21 plus 15 plus 10 plus 6 plus 3 plus 1. We have to add all these values. We have to add all these values for N of E. N of E. Anything. So instead of solving like this, just think like this. For example, I want to get the number of events which gets at least sum as 6. So I have to find out this. How can I find out? The sample space minus number of events which are not getting sum as 6 at least. Sum as 6 at least. So try to find out this now. That is N of S total sample space is 216 minus not getting sum as 6 means there may be a chance of getting 5 as sum. There may be a chance of getting sum as 4. There may be a chance of getting sum as 3. So what are the possibilities? 6 plus 3, 9, 9 plus 1, total 10. So 10, which is 206. So total there are 206 possible cases. That is, if you add from this 10 to 1 in this fashion, you will get a total of 206. Total of 206. Instead of adding this, I have taken this formula. So probability of occurring a event is nothing but n of e by n of s. 206 by 216, which is 103 by 108. Answer is 103 by 108. I hope it is clear. 103 by 108. Okay. Next one. Have a look here. These are related to pack cards. See, a pack card is drawn from a pack of 50 cards. What is the probability of getting a diamond? No, we know that in diamond king, there is only one king in each set. So, answer is 1C1 by 52 C1. So, answer is 1 by 50. Answer is 1 by 52. I hope it is clear. Next one. A queen of club or a king of heart. No, R means plus. R means plus. Now, have a look here. Have a look here. One queen. Club consists of one queen. So 1C1 plus 1C1. King of heart. Heart cards consist of only one king. By I am drawing only one card, 52 C1. So that is 2 by 52, which is 1 by 26. I hope it is clear. For pack card concept, refer to the video which I did on the pack cards. You will get some clarity. Anyhow, everyone is familiar with this nowadays. Now, face cards. Face cards. No, face cards means king, queen, jack. There are 3 face cards. Each set consists of 3. Total 4 sets. Total 4 sets. 4 into 3. 12 cards will be there. 12 cards. So, answer is, we have to get one card out of the face card. 12C1 by 52C1. That is 12 by 52. 12 by 52. Answer is 3 by 13. Answer is 3 by 13. I hope it is clear, sir. 3 by 13. Next one. Either heart cards or kings. Either heart cards or R means plus kings. Now have a look here. Have a look here. See, there are 4 heart cards. 4 heart cards. Out of which one heart card belongs to kings. One heart card belongs to, sorry, 1 minute. Sorry for that. Actually, there are heart cards. If you consider heart cards, there are 13 heart cards. 13 heart cards. And if you consider king cards, there are 4 king cards. But there is an intersection of one card which is king as well as heart. So we have to eliminate them. So intersection of one king card. Total, see, generally there should be 13 plus 4, total 17 cards. But there is one intersection card between king and heart. So eliminate that. So total 16 cards, 16 by 52. 16C1, strictly speaking, 16C1 by 52C1. That is 16 by 52, which is 4 by 13. 4 by 13. 4 fours are 413. I hope it is clear. Okay. Next one. Next one. A card having a prime number. We know that there are the number cards from 2 to 10 in each set. Each set, 2 to 10 cards are the number cards, out of which 2 is a prime number, 3 is a prime number, 5 is a prime number, and 7 is a prime number. Total 4 cards from each set. Okay, this is from each set. Each set. So total 4 sets are there. 4 fours are 16 cards will be there. 16 cards. So probability of the event is nothing but 16C1 by 52C1, which is nothing but 16 by 52, which is 4 by 13. I hope it is clear. 4 by 13. Option D is the right one. Okay. These are the primary set of questions related to pack cards. Next one. Have a look here. Anil plays a deck of 52 cards. If you pick one card, what is the probability that both are aces? Both are aces. We have to pick two cards randomly, and the condition given that both cards will be aces. How can I solve this question? Come on, both are aces. Since there are four ace cards, so it is nothing but 4C2 by 52C2. 4C2 by 52C2. Anyhow, the denominator is 2, it will get cancelled. So 4 into 3. Okay, for the first one, I'll write 4 into 3 by 2 into 1 divided by 52 into 53. Sorry, 52 into 51 divided by 2 into 1. 2 into 1, 2 into 1 gets cancelled. It will get cancelled. Now, have a look here. This is 4 13s 52. 4 13s 52. 7 17s 51. So, answer is 1 by 221. 13 17s 221. So, answer is 1 by 221. I hope it is clear, sir. I hope it is clear. Next one. Both are kings without replacement. Without replacement, both are kings. Have a look here. First card, I have to draw. There are 4 kings. So, 4C1, I have taken one card from the deck of 52 cards. That is king. And I am not replacing it. Okay, I am not replacing it. Both means must condition. That is into. Again, there are 3 kings. Since I have taken one king before, now the kings will be 3. So 3C1 by, have a look. First time, if I pick one card from the deck of 52, 52C1 into, next time, there are only 51 cards. Since I am not replacing it, so 51C2, sorry, C1. Or I'll tell you like this, have a look. I am taking one card at a time. There are 4 kings. 4C1 by, total there are 52 cards. 52C1 into, I am not replacing it. I am taking the card away. Next time, there are only 3 kings. 3C1 by, now there are only 51 cards. Since I am not replacing the previous card. So 51C1. Answer is 4 into 3 by 52 into 51. Again it is 1 by 220. 1 by 221. I hope it is clear, sir. I hope till in this video I have covered the problems based upon coins, problems based on dice, problems based on pack cards, problems based on pack cards. Now, in the next video, I'll cover the problem based on colored balls, next bulbs, and some miscellaneous questions. Thank you.